everyone, in this lesson we're looking at modeling data with polynomial functions. And you can use your graphing calculator to determine a model that best fits a set of data. We've been doing already a lot of practice with the regression capabilities of the calculator. In this lesson we're going to focus on linear, quadratic, and exponential models. And if you remember, the coefficient of determination, r squared, is a statistical measure of how well the regression line approximates the real data points. If r squared is close to 1, it's a really good fit, or when it's 1, it's a perfect fit. You can then use the best fit model to estimate values for your data. So the whole point of coming up with a model is that then we can make predictions about, future scenarios depending on the problem. So for the calculator, we have to make sure that we're turning diagnostics on first. So let's do that together. You're going to go to second, 0, and you'll see that when you go to the catalog, up in the upper right corner, A comes on. We are immediately get put into alpha mode. So we're going to scroll down to D, and D is the button highlighted in red right now. And that'll make it just a little bit easier to scroll down to diagnostics on is what we're looking for. You're going to hit enter, enter. And now when we do any kind of regression, we'll see the r squared value. If you don't do this step, you're not going to see it. Next thing we're going to do is we're going to enter the data into list 1 and list 2. That would be stat edit. And then we'll look at linear, quadratic, and exponential regression options using the calculator. So our first problem, the table shows winning times in the men's Olympic track and field 400-meter run. For 1968, let x equal 0. For 1972, x would be 4, and etc. And I filled in all the x values for you already. Whenever there is years involved in our data, we usually let x equal 0 at a starting year, and that just makes the data more accurate, and it's a little bit easier to enter in your calculator as well. So our x values will go in list 1, and our y values will go in list 2. So we're going to go back to our calculator, and we're going to enter in the data. We're going to go to stat, and edit is the first one. We're going to hit enter. Oops, now I have data in there. I should have reminded you to clear your list first. So let's quit out of here, second mode, and we're going to clear our list. Second, plus sign, and we're going to do number 4, enter, and now all the lists are cleared. So let's go back, stat, enter, and we're ready to go. So we're going to enter our x values into list 1 and our y values into list 2. All right, and it really is worth it once you feel you've entered all the data that you go back and just take a quick look at it again and make sure all the values are entered correctly. At this point, we can quit out of the list. And let's go back to the problem. We're being asked to find a linear, a quadratic, and an exponential model, and we're going to round all values to the nearest thousandth, and then we'll circle the best fit model. All right, so let's do linear first. We're going to go to stat, calc, number 4. And it should be list 1, and if it's not, you're going to do second 1, and then we want list 2, second 2, enter. We're not going to store the equation yet. We have to decide which model is the best. So we'll worry about that later. Highlight calculate and hit enter. And now we're going to copy down that equation onto our notes. And we also want to note what the r squared value is. And in this case, the r squared value right here is 0.367. Now we want to check for the quadratic model. We're going to go to stat, calc, and we're going to choose number 5 for quadratic. List 1, list 2, calculate. We'll copy that model down. We'll go back and look at the r-squared value, 0.452. All right, so far we know the quadratic model is beating the linear model because we have a higher r-squared value. We're closer to 1 with the quadratic model. All right, last one we're going to check is the exponential model. All right, it's at 0 there. It's this guy. We're going to hit enter. List 1, list 2, and calculate. And we'll write that down. Let's look at the r-squared value. The r-squared value is 0.367. And if we're looking at linear, quadratic, and exponential, it looks to me like the quadratic model is our best fit model because we have the highest r-squared. Now, if you go back to your calculator and you go to stat calc, you'll see that there's lots of other models we could try. We could try cubic, we could try quartic, and you might find a better fit. We're just going to stick with these 3, but there could be other models that are a better fit. But from the ones that we observed, the quadratic model is the best fit. So now it says, based on your chosen model, what should the winning time be in 2018? Well, 2018 is 50 years past 1968, so that means our x value is going to be 50. If we put the value of 50 into this rounded equation, we would get one answer, or we could use the exact model that's in the calculator. I really prefer that way, so I'll show you both though. Let's go back to the calculator, and we know that the quadratic regression equation is the best, so we're going to go and choose the quadratic regression model, so stat calc quad reg. And this time though, since we know this is our best fit model, we're going to store the equation into y1. So we're going to go to vars, y-vars, and we're going to choose number 1 function, and we're going to choose y1. Hit calculate, and now that whole equation is stored in y1. So if we go to y equals, there it is. That means that I can use that equation in my table. I can look at the table for the value of 50. So if I go to second graph, I'll get to table. Now my table set all weird, so I have to fix that. I'm going to go to table set. It's right above window. So we're going to go to second window, and we're going to set the table. I want to start my table at the value of 50 because that's the prediction value I'm using. And we usually will change the table at increments of 1. So I'm going to change that to 1. Now I can go back to my table, second graph, and we can see that I have an output value of 41.979. Now I'll show you if you wanted to use the rounded model, what we would do. We want to store the value of 50 into the x. So we're going to go to second mode to get out of here. And we're going to do 50 store x. Right now, storing the value of 50 into x isn't going to affect any other screen in your calculator or any graph or anything. It only affects what happens on the home screen of the calculator. And now we'll type in the equation. And we'll hit enter. And we get a value of 42.536. So usually I would accept either answer if it was a paper and pencil test, but if you were taking maybe a multiple choice test, I would probably note to you that you need to use the calculator table answer. All right, and the next thing we want to do is say, well, does this estimate seem reasonable? Well, we want to go back and just pay attention to the fact that our r-squared value is 0.452. That's about 0.5. It's not even halfway to the value of 1. The closer we are to 1, the better the model fits the data. So this model is not going to be really super accurate, but that's the one we're going with. So over time, it looks like seconds it took to do the run actually did improve over time, no matter which answer you look at here, right? These times are both better than this one, and that's what we would expect. So I would say yes, since the time did improve over the long term, it's reasonable. All right, so that's really the whole process. Now we're going to try it with some more practice with number 2 and 3. I would suggest that you try those on your own, and when you're ready, you come back and check your answers. The table below shows the men's Olympic springboard diving records. For 1980, we're letting x equals 0. 1984, we're letting x equals 4, and so forth. So these are the values that would go in list 1. These are the values that would go in list 2. Go to our calculator, and we're going to clear the list. Second, plus sign, number 4. We'll go to Stat, Edit. We'll enter our list 1 values in and our list 2 values in. Now that your data is entered, take a few seconds just to take another quick look at it. Make sure all the values are entered correctly. Then we're going to do second mode to quit out, and we're going to calculate all the models again. So we're going to go to Stat, Calc, and we're going to do linear regression first, number 4, list 1, list 2, and calculate. And we'll write down that model. R-squared value here is 0.603. Now we'll go back and do quadratic, Stat, Calc, number 5. And we'll write down that model. And the last one, exponential, Stat, Calc. And I'm going to use the up arrow. It might be a little quicker to get to. Enter. And we'll write that down. All right, and it looks like, again, the quadratic model is the winner because we have the highest R-squared value, and this is a really nice R-squared value, 0.9. We're almost at 1. We know that this quadratic model is a really good fit for our data. Now it says, based on our model, what should the winning time be in 2018? So 2018, that's 38 years after 1980, so x equals 38. I'm going to look at my table, but I have to make sure I store the quadratic model into my y equals. So we'll go to Stat, Calc, number 5, vars, y vars, enter, enter, and we'll do calculate. And we'll look at the y equals, and we can see it's stored there. And now we're going to go to second table, and we're going to set our table to 38, and second graph. And for the value of 38, we get 1316.6. You could also use your rounded model. So what we would do is we would store 38 now. We would do 38, store x. We would type out the model, and I just find this to be a lot more tedious, but I know some people prefer it, so I'll show it to you again. Hit enter, and this time for the rounded model, we get 1317.073. And they're both really close, but I mean, this first one is the more accurate one. So it says, does your estimate seem reasonable? The points increased over time, which is what we would be expecting. I mean, over here, in the year 2000, we got about 709 points, and now we're saying in 2018, we're getting around 1,300 points. All right, last one, number 3. The table below shows a recent graduate's credit card debt each month after graduation. So we're going to enter the month data in list 1 and the debt in list 2. Second plus sign to clear your lists. Stat, edit. We'll enter in our data. All right, like I always say, check your data very quickly again. Just give it a quick look. Make sure you're not, everything is accurate. And we want to quit out, second mode. We're going to go to Stat, Calc, number 4, enter, enter, enter. Write that down. Then we'll go to Stat, Calc, Quadratic, number 5. Write that one down. And last one, we'll go to Stat, Calc, we'll choose 0, exponential regression, calculate that model. And we'll write that one down. And it looks like all of our models are a really good fit for the data. They're all close to 1, but the best one is this one right here, the exponential model. So it says, based on your model, what will the debt be 12 months after graduation? So that means that we're looking at a value of x equals 12. So we want to go back to our calculator and we want to store the exponential regression equation into our calculator. Go to vars, yvars, enter, 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 calculate. And if you go to y equals, you'll see it there. It's always a good step to check it in y equals because a lot of times people forget to do that last step. And then we're going to go to table set, second window. And this time I want my x value to start at 12. Just being lazy, I just don't want to have to move around my table. I want to go to my table and I want to be right at the value of 12. All right, and I get 4,094. And that's the value that I get from the calculator table. Or like we said, we can store the value into x and use the rounded model. So let's do that next. Second mode, we're going to store the value of 12 into x. Type out the model. And when we use the rounded model, we get 4,095. Really, really close to the table value we got. So what we're trying to decide now, is this reasonable that we would have $4,000 in debt at 12 months when I was about, almost $2,000 in debt at 8 months. So I think that seems reasonable. It makes sense that the graduate would have accrued more debt over time. All right, everybody, that's all I have for this lesson. I hope you enjoyed it. Have a great day.